Alright, so in this video, we're going over volumes of revolution. Now, what exactly does that mean? Well, before, when we integrated, we would integrate two-dimensional figures. Like for instance here, if this was the line, say y equals 2, okay, and say this was x equals 2, we would integrate this from 0 to 2, something like this, 0 to 2 of f of x dx. Okay, take the antiderivative and we find the area of that square. Or same thing here. Say this was the line y equals x. Again, we would just simply integrate it and find the area. But now we want to find the volume. Well, you might say, how do you turn a two-dimensional figure into a three-dimensional figure so we can find volume? Alright, that's where this revolution comes from. We're going to revolve them around the x-axis. Okay, so we're taking this and we're now spinning it around the x-axis. Alright, so if we were to spin a rectangle around the x-axis, that rectangle now becomes a cylinder. Okay, that rectangle now becomes a cylinder. If we were to spin this little triangle here around the x-axis, it would become a cone. Okay? If we were to spin that around it, it would become a cone. Now, how do we figure out what the actual volume of these things is? Okay? Well, if you remember your formula for cylinder, okay, area for a cylinder is pi r squared, because both ends are circles, times the height. So basically you're taking all these little slices and you're adding them all together. And that's how you're getting your volume. It's basically the same thing with a cone. Okay? Now, so basically what you're doing here is when you slice this, you get circles. Alright? And don't forget the area of a circle is pi r squared. Well, in this case, our radius is simply our function. Because if you think about it, radius, it's the distance from the x-axis up. Well, that's just simply your y value. Alright, so we're going to get to our problem in a moment. But basically now when we integrate, we're going to integrate our function, and we're going to end up having to multiply by pi, to put it simply. Okay? So let's look at an actual example, and it might, clear some of this up a little bit. If we wanted to just integrate this normally, all right, we'd go from a to b, and you'd have your function f of x in here. Okay, we'd integrate that dx, and boom, would have our area. All right, but now we want volume. So how do we have to modify this? Well, if you remember, all those little circles are going to all add up. Well, basically, when we integrate this, we're adding up all, like if you did, instead of circles, you did little tiny rectangles. This is basically adding up all those little tiny rectangles. So now we just kind of have to convert this in order to do circles, so we can add up all those little tiny circles we're going to get. Well, remember how I said that your function now becomes your radius? And your area of a circle is pi r squared. So basically, we're going to modify this formula now. We're going to be pi, our function, f of x, squared. Alright, our function, f of pi times our function squared. This is your formula for the volume. Oops, almost left the b out. That is your formula to find the volume. And we're actually going to do this problem. So write this down, somebody erase it. And we're actually going to do this problem right here. Okay? So just remember, basically all we're doing is we're just making little itty bitty tiny circles all the way up this. And we're just adding up all the little circles. Alright? Hopefully you wrote this down. I'm going to get rid of it. So we want the volume of this. It says, find the volume of the solid of revolution generated by revolving f of x equals x over 2 around the x-axis. It's important to pay attention to which axis you're revolving around. Okay, we're revolving around the x-axis. So, our volume, going back to our formula, is going to equal a to b. In this case, it's 0 to 4 pi times x over 2 squared dx. Okay? So go ahead and square that out. So we're going from 0 to 4 pi x squared over 4 dx. Okay? You can pull the pi over 4 out. I'm going to do it down here. You can pull the pi over 4 out and just leave it out front. So then you're integrating from 0 to 4, basically just x squared dx at this point. Okay, so we have pi over 4 times, this is going to go to x cubed over 3, evaluated from 0 to 4. Of course, plugging the 0 in is not going to do anything. So you're going to have pi over 4 times, since this is 4 cubed, and you have a 4 here, it'll actually make this just 4 squared. So 4 squared is 16 over 3. Okay? And so we can get rid of this guy too. So our final answer here is going to be 16 pi over 3 units cubed, because now we're talking about area. Alright? Now we're talking about area. So, just a quick review before I do one more problem. We have our function, x over 2, and basically we're plugging it in for the radius in the formula for area of a circle. Pi r squared, pi, our function squared. Alright, so go ahead and square that out. Pi x squared over 4 dx. You can pull the pi over 4 out because they're constants. So the pi over 4 times the integral from 0 to 4 of x squared dx. That equals pi over 4 times x cubed over 3, which equals pi over 4 times 4 cubed over 3. The 4 cubed and the 4 will cancel to just 4 squared. Okay, so it's pi times 16 over 3, which is 16 pi over 3. And then that's your area. When you revolve this around like this, and you get that cone, the area of that cone will be 16 pi over 3. Alright, let's look at one more of these before we call this video finished. Alright, so we want to find the volume by spinning, whoops, I can spell, by spinning f of x equals the sine of x around the x-axis. Alright, so draw it out. Pictures help a lot. Alright, oh, I forgot to from 0 to pi. 0 and pi, our function is sine x. Okay, so we plug in our formula. Volume equals from 0 to pi of pi times sine of x squared dx. So now you're going to integrate this. Of course, you've got to take the antiderivative and all that, but once you do, you will get 4.935. Okay, so antiderivative. So again, you could pull the pi out. 0 to 4 of sine squared x dx. So take the derivative of sine squared, evaluate it from 0 to 4, multiply it by pi, and you're left with almost 5. Alright? So, that's your volumes of revolution video. Make sure you understand, the concept being taught here. You can watch the video again if you want to. We'll work on some problems tomorrow in class. See you tomorrow.